Good morning to our Honorable Dr. Noor Ashiki and my dear fellow friends. My name is Arvind. I am from Group 5. So today, we, me and my fellow groupmates are going to present about formation evaluation for simple lithology. Without wasting time, let's move to the introduction part. As you can see in the slide, there is a spider web. So let me explain about the picture in a while. So formation evaluation is an important analytical process existing to the identification of economical production of the reservoir. It is a well log analysis and also the petrophysics analysis. So formation evaluation is actually used to determine the presence of reservoir rock, evaluate the reservoir for potential hydrocarbons, and also to estimate the volume of hydrocarbon in the reserves. So it also used to develop reservoir mechanical properties models for the drilling and producing departments. So as you can see in the picture given in the slide, so formation evaluation is actually providing information to all other departments such as mechanical properties, exploration, geophysics, and also subsurface, economics, and also EOR and production.
Assalamualaikum, my name is Muhammad Faiz bin Sukri, and now I'm going to present about formation evaluation principle. To begin with, the overall purposes of well logging is to provide a continuous profile of lithology with exact depth of formation, rock properties and rock composition, mechanical rock properties, indication of content and properties of other substance, seismic relevance parameters, and lastly, change of properties. Next. Okay, next is type of well logging. Well logging can be classified into three categories, which is open hole logging, case hole logging, and production logging. Next is open hole logging. Open hole logging is logging survey taken before the hole is cased. And the logs included in this group are electrical survey, sonic logs, caliper logs, deep meter logs, SP logs, and radioactive survey. Okay, next. Okay, next is case hole logging. Case hole logging is logging surveys taken after the casing is lowered and are usually categorized as case hole logs. The surveys included in this group are gamma ray, neutron temperature, pulse neutron, cement bond log, C/O, and sigma log. And next we have production logging. Production logging is well logging surveys taken to improve production or repair the well. And surveys included in this category are flow meter, pressure, temperature, and fluid density. Okay, next. Okay, we proceed to the next part, which is qualitative law interpretation techniques. And it is a flow diagram of the techniques, which is we identify the rock first and differentiate whether it reservoir or non-reservoir, and then we differentiate further between hydrocarbon bearing and water bearing. The analysis of log data to identify the potential hydrocarbon zone is an important aspect in log analysis, and a scanning technique is required to sort out the reservoir from non-reservoir. And for differentiating reservoir and non-reservoir zone, following logs are used, which is caliper logs, gamma ray logs, SP log, and density and neutron logs. Okay, next. And for differentiation of water-bearing and oil-bearing zone in the reservoir, we use SP log, sonic log, density log, neutron density log, and resistivity log. And here you can see the response in hydrocarbon-bearing zone and response in water-bearing zone for each log type. And that's all from me. Thank you. I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Raziri bin Asno and metric number TH18010. I will continue about water resistivity determination. Water resistivity can easily be found by spontaneous potential log (SP) curve read in clean formation. The spontaneous potential log is given the generic economic SP and it can use for water resistivity determination. There are three methods that can determine the water resistivity. First, quick loop method, second, single chart method, and third is Smith method. Here at the bottom you can see the quick loop method, at the middle single chart method, and the right side is a Smith method. Then the cross plot utilization is a two-dimensional plot with one variable scale in the vertical y direction and the other in the horizontal x axis. The common cross plot used for simple lithology is neutron density. In some zones, porosity record on the log differ for three reasons. First, the metric density used by the logging program for calculation porosity is different from the actual formation metric density. Second, gas is present in the formation pore space. Third is shell or clay is present in the formation. And the Hingle and Picket plot is Hingle plot is porosity resistivity cross plot is often called the Hingle plot after the man who first published the method. On Hingle plot graph paper, the saturated line fan out from the zero porosity infinite resistivity point, and the Picket plot is a visual representing of the equation and therefore is a powerful graphic technique for estimating water saturating range within a receiver. All that is need to make Picket plot is a set of porosity and corresponding resistivity take from the well log and 2 time cycle log to log paper. At the right side you can see the Hingle plot and the Picket plot. That's all for me, and I will pass to the next presenter. Thank you.
Hello and Assalamualaikum madam. My name is Ahmad Syami Betajalasa with the ID number of TH19006, and now I will present about the graphical interpretation of techniques for porosity and lithology. Porosity determination using the most of logging device represented on the knowledge that of the parameters related to the type of the rock is investigated. Determining these parameters is not much a problem for those who are good at the geological knowledge for the formation, and if the lithology is encountered are simple, such as clean sandstone or limestone reservoir. So this is a type of graph that graphical method that can be used to gain the graphical interpretation of techniques for porosity and lithology. This is the first one, which is the plot is a density sonic cross plot. This is second one. This is the third one with the formula of rho b equal to density of rho f1 plus 1 minus porosity times with the rho ma.
Moving on to the next part, which is the saturation determination via Archi equation. As you can see in the slide, it shows the Archi equation. It was the first empirical model built in 1942. It is functions to determine the water saturation in non-conductive metric rocks. It usually works well with the clean clastic sandstones and also carbonate rocks. It is now used to calculate well log parameters, the water saturation of the uninvaded zone in formation next to the borehole. So as you can see in the formula, SW is the water saturation, N is the saturation exponent, and RW is formation water resistivity, and the porosity, M is cementation exponent, and the RT is true resistivity of the formation.
For the hydrocarbon effects on log readings, this is a statement of the basically the three most important points to well site interpretation are hydrocarbon information, the quantity for hydrocarbon information, and the recovery of hydrocarbon itself. Hydrocarbon information is the selection of the appropriate zone must be addressed. It is not that formalities with low shell content are most likely to produce accumulated hydrocarbons. Thus, the first task is to identify the zones with low volume fraction of shell, also known as a clean zone. This is the work of the work chart with number 1 to until number 3. This is for the quantity of the hydrocarbon information. The condition is possible only if the formation is porous. Porosity increase, the bulk density decrease. Which is recovery. Another common resistivity measurement RSO correspond to the resistivity of the flush zone, as well as this one. This is basically the summarize of this, which is clean or shelly, which is GP and SP and GR. Sorry, which is when GP and SGR, when V shell is increases, so is the SP and GR. For the porosity, the density, Newton, and the neutron, and acoustic. When the porosity is increases, the rho B, the porosity N, and delta T was also increases. For the hydrocarbon, which is the measurement is RT, when the viscosity of water increases, so is oil increases, and this is porosity increases, RT would decrease, increase, and increase. This is basically the summary of those 3 points. And finally, we have this formula for the porosity D, and then we have the formula for the porosity itself. Thank you, madam, for listening to my presentation.
As a conclusion, me and my fellow groupmates have more understanding on formation of evaluation, and also we can conclude that formation evaluation is the fundamental step for the reservoir research, where it provides information to various departments such as exploration, geoscience, and economics, and also production. That's all from us. Thank you.